America's biggest airlines are making a multi-billion-dollar gamble that defies basic logic. In January 2026, Alaska and Delta Airlines wrote checks for hundreds of new Boeing aircraft. But here is the terrifying part for their investors. They are betting their entire corporate futures on planes that aren't even legally allowed to fly yet. Why are the world's most powerful CEOs pouring billions into uncertified aircraft like the radical 777X with its massive folding wingtips? Because they know a secret. This isn't a simple fleet upgrade. It is a high-stakes survival game to prepare for a fundamental shift in how global aviation operates. Today, we are breaking down the revolutionary Boeing tech airlines are risking everything on. The billion-dollar math behind the scenes and why picking the wrong plane today could bankrupt an airline tomorrow. Let me start with the credibility piece. Boeing just posted their strongest year since 2018, outselling European rival Airbus with over 1,100 aircraft orders. The Federal Aviation Administration approved production increases that will put more Boeing jets in the sky than we've seen since before the 737 MAX crisis, and financial analysts from Bernstein to Susquehanna are setting price targets near $300, calling Boeing one of their best investment ideas for 2026. Here's what we're covering today. First, I'll show you the revolutionary technology that's got airlines excited. From engines bigger than subway tunnels to wings that literally fold themselves. Second, we'll dive into the business case that makes spending billions on unproven aircraft seem logical. Third, I'll explain why the timing of these orders matters more than the aircraft themselves. And finally, we'll look at the competitive dynamics that are forcing airlines to choose sides in the biggest aviation rivalry since Airbus challenged Boeing decades ago. Let's start with the technology revolution happening inside Boeing's manufacturing facilities in Everett, Washington. The Boeing 777X represents the biggest leap in wide-body aircraft design since the original jumbo jets. Picture this, an aircraft that can carry 426 passengers across distances that would require fuel stops in older planes powered by engines so large they could house a small apartment. The GE9X engines spinning beneath the 777X's wings are the largest commercial aircraft engines ever built, generating over 105,000 lb of thrust each. But the real breakthrough sits at the wing tips. The 777X features 3 and 1/2 folding wing tips that extend during flight to create a 71.8 m wingspan. This isn't just an engineering marvel for its own sake. That extended wingspan creates aerodynamic efficiency that translates directly to fuel savings, while the folding capability means the aircraft can use standard airport gates without requiring infrastructure changes that would cost billions. Meanwhile, the 787 Dreamliner, that's driving much of the current ordering frenzy, represents proven technology that's already changing how airlines operate. The 787's composite construction makes it 25% more fuel efficient than the aircraft it replaces. For an airline operating dozens of daily flights, that efficiency translates to millions of dollars in annual fuel savings. Alaska Airlines CEO Ben Minicucci stood in the Seattle Delivery Center next to their first 787, painted in the airline's new global livery. Featuring Aurora Borealis-inspired colors that took artists nearly 1,000 hours to apply. But behind the beautiful paint job lies technology that will enable Alaska to fly non-stop from Seattle to European destinations that were previously impossible with their fleet. The 787's range capability means airlines can open routes that bypass traditional hub airports. Instead of connecting through congested airports in New York or London, passengers can fly direct from secondary cities to international destinations. This point-to-point flying model is reshaping airline route networks and creating new revenue opportunities. Delta's recent order for up to 67 87-10 aircraft, the largest variant in the Dreamliner family, signals their intention to compete on transatlantic and South American routes where fuel efficiency determines profitability. The 787-10 can carry 336 passengers while burning 25% less fuel than older wide-body aircraft, creating a significant cost advantage on high-density routes. Now let's examine the business case that makes these billion-dollar investments logical for airline executives facing quarterly earnings pressure. The mathematics of airline profitability revolve around a simple equation. Revenue per seat mile minus cost per seat mile equals profit margin. When fuel represents 30 to 40% of an airline's operating costs, even small improvements in fuel efficiency create massive bottom-line impacts. Consider Alaska Airlines' business model. They operate in markets where passengers expect low fares but demand frequent service to destinations like Alaska and Hawaii. The 787's efficiency means they can operate these routes profitably at lower fare levels while offering more frequency than competitors using older, less efficient aircraft. Delta's strategy focuses on premium international routes, where their 787-10 aircraft will compete against Airbus A350s operated by European carriers. The 787's lower operating costs allow Delta to offer competitive fares while maintaining profit margins that support their dividend payments and fleet renewal programs. But fuel efficiency represents only part of the value proposition. These new Boeing aircraft enable airlines to optimize their route networks in ways that weren't previously possible. The 777X's range of over 8,000 nautical miles means airlines can connect city pairs that previously required fuel stops or aircraft changes. Emirates has publicly discussed using 777X aircraft to launch non-stop service from their Dubai hub to destinations in the Americas and Australia that currently require connections. Each new non-stop route represents potential revenue that competitors flying older aircraft cannot capture. The aircraft's passenger capacity also creates economies of scale on high-demand routes. The 777-9's 400-passenger capacity means airlines can serve routes with fewer daily flights while maintaining total seat availability. This reduces airport slot costs, crew expenses, and maintenance requirements while improving aircraft utilization rates. Boeing's latest production data shows they're delivering aircraft with reliability rates that exceed older generation jets from the first month of service. This operational reliability translates to reduced maintenance costs and improved on-time performance that drives customer satisfaction scores. The timing of these massive aircraft orders reveals strategic thinking that goes beyond simple fleet renewal. Airlines are positioning themselves for a post-pandemic recovery that's creating unprecedented demand for air travel while simultaneously preparing for regulatory changes that will reshape the industry. Boeing received Federal Aviation Administration approval to increase 737 MAX production to 42 aircraft per month, the highest rate since before the aircraft's grounding. This production increase comes as airlines face aircraft shortages that are limiting their ability to add capacity on domestic routes, where demand has returned to pre-pandemic levels. Alaska Airlines' order for 100% and 5 737-10 aircraft extends their delivery schedule through 2035, ensuring they'll have access to new aircraft even as Boeing's production slots fill up.